Hello everyone, welcome back to my channel. My name is Soumya. In today's video, I'll be doing this lab on introduction to Docker. In this lab, you will learn how to build, run and debug the Docker containers, how to pull the Docker images from Docker app and Google Artifact Registry, how to push Docker images to the Google Artifact Registry. So this is a 1 hour lab. As I will be explaining each and every steps and the task performed as part of this lab. So please stay tuned until the end of this lab. So let's start the lab. I'm in the Google Cloud Console. Here you need to first activate the Cloud Shell. Click on continue. Now let's copy this gcloud auth list and authorize our Google Cloud Console. So authorize this Cloud Shell. If you want to set the active account, you can execute this command. So as part of this lab, this is the first task, hello world. In Cloud Shell, we need to execute this docker run hello world to run a hello world container. So let's copy this command and execute it here. Here Docker refers to the Docker CLI. CLI is nothing but the command line interface. So we issue this command to interact with the Docker daemon, which manages Docker containers and images. And here run is a command which is used to create and run a container based on an image. So here in this case, hello-world is a special image provided by Docker, which is commonly used for testing and verifying the Docker installation. So when we execute this command, docker run hello-world, these are the actions which takes place in the backend. Docker CLI will communicate with the Docker daemon and instructs it to pull the hello-world image from the Docker hub. Here Docker hub is a public registry which holds the Docker images. So first it will try to search for the hello world image locally. If it is not present, then it will pull the image from the public registry, which is nothing but Docker hub. Once the image is pulled, Docker daemon creates a new container based on this image. So the container is isolated and lightweight runtime environment that contains the necessary components to run the application specified by the image. Here hello world image contains a simple program that will print hello from Docker message to the console. So as you can see here, you got the message hello from Docker. If you get this message, then this indicates that the installation worked correctly. Once this execution completes, the container exits. Overall, docker run hello world is a simple command which can be used to quickly test the Docker setup. So let's move ahead with the next task. We have to execute docker images command. So let's execute this command. When you execute docker images command, it will list all the docker images that are currently available on the system. So here you can find a table with details about each image. In our case, we have only one image. In the backend, Docker CLI communicates with the Docker daemon running on your system. Then Docker daemon retrieves information about all the Docker images stored locally. Docker daemon then will display a table showing all the information, including the repository, the name of the image, tag, image ID, creation date, and the size. Like it will show the disk space occupied by the image. When you issue this command, it will provide an overview of the Docker images which are available on your system. This will be very helpful for you to manage your Docker environment, as you can see which images are present, their versions and their sizes. If you are hosting multiple images, you can get those details by executing this docker images command. By this way, you can also keep track of the images available for creating containers or managing your Docker environment efficiently. Let's run the container. Let's copy this command docker run hello world. I will explain what this does. Let's execute this command. So here we can see when we execute this command again, it's not pulling the image from the Docker hub because here So Docker daemon was able to find this image on the local registry, and it then ran the container from that image. So it doesn't have to pull this image from the Docker up. Now let's move on and execute this docker ps command. So let's copy this command and execute it here. This command docker ps is used to list the Docker containers that are currently running on your system. When you execute this command, Docker will display a table with details about each container, such as the container ID, image used to create the container, command being executed, container status, creation time, and the ports being mapped. But when we executed this docker ps command, it didn't show any container because there are no running containers. We already exited the HelloWorld containers that we previously ran. If you want to see all the containers that have finished executing, we can execute this command docker ps-a. So let's copy this command and execute it here. So this will show all the containers which also exited. So under status, you can find there are two containers which ran and it exited. So it's showing details about this. So now you can make out the difference between docker ps and docker ps-a. So docker ps will list all the containers which are running. Docker ps-a will show even the containers which are exited. These names are randomly generated. If you want to have a custom name to your container, you can pass it when you are running the docker run command. You can pass a variable like hyphen name and provide the name of the container. So you can execute this docker and hyphen name, and you can provide the container name here and then provide the image name. So this way you will be creating a container with your custom name. So let's move ahead with our task to build. In this section, we will be building a Docker image that's based on the simple node application. So let's execute this command. So let's copy this command and execute it here. So here mkdir test, it will create a directory by the name test, and later it will cd to that directory. Now you can see we are inside the test directory. Here let's create a Docker file. Let's copy this and execute it here. So here you can see a Docker file got created. Here the first line from node colon LTS specifies the base image for your Docker image. In this case, it is using the official Node.js runtime image with the LTS tag. So this means your image will be based on the Node.js environment. Next line. So here we are setting the working directory inside the container to /app. In the third line, we are giving add./app. So this line copies the contents of the current directory. So this is the directory where the Docker file is located into the /app directory inside the container. So this ensures that all the files and folders in the current directory are included in the Docker image. Next, we are running expose 80. So this line declares that the Docker container will listen on port 80. It specifies that this port should be made available to the outside world when the container is running. Finally, cmd node app.js. So this line will set the default command to be executed when the container starts. It specifies that the command to be executed is node app.js. So this indicates running the app.js file using the Node.js interpreter. Overall, this Docker file defines an image based on the official Node.js runtime, sets the working directory, copies the local files into the container, exposes port 80, and specifies the command to be executed when the container starts. This Docker file can be used to build an image that runs on a Node.js application. Let's move ahead. We need to execute this to create a node application. Let's copy this and execute it here. So this is a simple HTTP server which listens on port 80 and returns the message hello world. Now we need to build the image. So let's copy this. So here Docker is the CLI, whereas build is the command to build a Docker image. And -t is a flag which allows you to specify a name and tag for the image. So in this case, we are setting the name to node-app and the tag to 0.1. So the name and tag can be chosen based on your preference, or if you want to represent a specific version of the image. Here the dot represents the build context. It specifies that the Docker file and any other necessary files for building the image are located in the current directory. So when we execute this command at the backend, this is what happens. So the Docker CLI reads the Docker file in the current directory specified by the dot, which contains the instructions for building the image. The Docker daemon starts the build process using the instructions from the Docker file. It then follows the steps which is defined in the file, such as pulling the base image, creating a temporary container, executing the commands, and configuring the image. As the build progresses, Docker will display the output of each instruction, showing the build steps and any output from the commands executed in the Docker file. So once the build process completes successfully, Docker creates a new image with a specified name and tag. The image contains the configured runtime environment dependencies and any other file specified in the Docker file. So let's execute this command. So as you can see, it is executing all the commands one by one, whatever we have defined in the Docker file. Execution is completed now. Now let's execute Docker images command again. So Docker images will show the images which got created. So as you can see, we have this node-app. Node-app is the image that we just built. Now let's move ahead with the task 3 run. So let's copy this command. So this is used to run a Docker containers which is based on the node-app image with a tag 0.1. Here -p flag is used to map ports between the container and the host system. So in this case, it will map the port 4000 on the host to port 80 within the container. So this means that any traffic sent to port 4000 on the host will be forwarded to port 80 in the running container. So here we are setting the name to my-app. Node-app colon 0.1 specifies the name and tag of the image that the container will be based on. So when we execute this command, Docker CLI will communicate with the Docker daemon and instructs it to run a new container based on the node-app colon 0.1 image. The Docker daemon then will create and start a new container using the specified image. The -p 4000 colon 80 flag maps port 4000 on the host system to port 80 within the container. So this will enable you to access the services running inside the container through port 4000 on your local machine. And here the name my-app flag assigns the name my-app to the running containers. So you can refer to this easily at later point. Now the container will continue to run and you can interact with the services within the container through the mapped port on your local machine. So here in this case, we have used port 4000. So the container will then use the configuration and application which is defined in the node-app colon 0.1 image to serve your Node.js application. So let's execute this command. So it is starting the server. So the server is running at this. Here the -p instructs Docker to map the host port 4000 to the containers port 80. So without port mapping, you will not be able to reach a container at localhost. So now the server is running at this local address. So in another terminal, let's execute this command. So here you can click on plus icon and it will open a one more terminal here. Here we need to execute that command. So let's execute that command. So here we are receiving a message, hello world. Let's move ahead with the lab. So we can specify -d flag if we want to run the container in the background. So until this is running, we will get this message over here. So again, if we execute this command, so we'll get that message, hello world. Let's close this terminal. And then we will execute this command docker stop. Let's execute that command here. Docker stop my hyphen app and docker rm my hyphen app. When we execute this command, docker CLI will communicate with a docker daemon and instructs it to stop the running container with a name my hyphen app. The docker daemon then will send a termination signal to the container, allowing it to gracefully shut down. So this will allow the container to save any necessary data or perform any cleanup task before stopping. Once the container is successfully stopped, the Docker CLI then proceeds to remove the stopped container with the name I-app. This permanently deletes the container and any associated resources, freeing up the disk space. So with this one command, we are stopping the running container and then we are removing it. So here you can see we have stopped the container and we have removed it. Let's execute this command. As you can see, docker run -p. This is port number. I have already explained it. So only one thing which is new is -d. So -d we are specifying here so that the container runs in a background. So let's copy this command and execute it here. So here when you execute this docker ps, it shows the container and this container is running in a background. When we execute docker logs, we have to provide the container ID. So let's do that as well. This is a container ID. So let's copy this and execute this. So here it shows container is running. Now let's modify the application. We'll navigate to cd test. Here we have to edit this app.js and we have to replace the hello world with welcome to cloud. So we have to replace this message. So let's go here and do ls. So here we have app.js. So I will be using the vi editor here. So let's edit this file. You have to change the message from hello world to this one, welcome to cloud. So we have made the changes. Save this file. Okay, now the file is saved. So again we need to build this new image and tag it with 0.2. So this is the next version. First we had node-app 0.1 version. Now let's build this new image and tag it with 0.2 version. So let's copy this, execute it here. So now the action is complete. So we are using the existing cache layer. This is a step 2. In step 2, we are using the cache layer. And from step 3, since we have made changes to app.js, it is executing all the layers again. Here you can see the layers are modified, hence it is running it again. So let's now run the container with a new image version. So here we will be using the port 8080 and we will not be using 4000 because this port is already used. So let's copy this and execute it here. We can't use the port which is already used by another container. So we have given a new port here. So now you can see we have two containers. So this was the first one which I created. So this is the first container with tag 0.1 and this is the second one which we just created. So here you can see under ports how it is mapped. Like here we are using 4000, here we are using 8080. Okay. Once that is done, let's test the containers by executing this curl command. It should display the message welcome to cloud. Check for first container with a port 4000. So it's showing a hello world message. So now both the containers are healthy and running. Now let's move ahead with the task 4 debug. We can get the logs of the Docker by executing docker logs -f followed by the container ID. So let's check the logs of the container by executing this command. So before that, let's get the Docker container ID by running command docker ps. So you will get the container IDs. Now let's run docker logs -f followed by the container ID. So when you execute this command, you should get this output. So this output you should get. If you want to start an interactive bash session, you can execute this command docker exec-it. So let's copy this. You need to provide the container ID here, followed by bash. So now you can see you are inside the bash. The -it flags will let you interact with the container. So as you can see here, we are inside the bash and we are inside this working directory slash app. So this is the working directory which we have specified in our Docker file. So let's ls here. So here you can see Docker file and app.js. You can exit this bash by typing exit. So now you are out of the bash shell. You can also examine the container's metadata by executing this docker inspect command. So every time you have to provide the container ID to which you want to debug. This way you can inspect the container. Whatever container you want to debug or get the logs of the container, you can utilize Docker logs and Docker inspect and provide the container ID and get the logs. You can also use -hyphen format method. Now let's move ahead with the task by publish. In this task, we are going to push the image to the Google Artifact Registry. But before pushing any image to the Artifact Registry, we need to create a repository there. So let's go to the console and navigate to this Artifact Registry here. So here we need to create a repository. So click on Create Repository here. And here let's give the name. So let's take this name, My Repository. Here you can see there are different formats available. Docker, Maven, NPM, Python. So since we are pushing the Docker image here, so we will select it the format as Docker. Here under mode, we'll keep it as standard. Under region, let's select US Central. This one I will select. Under encryption, we'll keep it as Google Managed Encryption Key. Click on Create. So this will create a repository. Now the repository is created. So let's move ahead. So before we push or pull any images, we have to configure Docker to use the Google Cloud CLI. So let's set up the authentication to Docker repositories. So we need to execute this command gcloud auth config -docker and specify the location. So we have created in US Central. So we'll be providing that. We need to execute this command so that we enable the authentication. So let's copy this and execute it here. So now it's updated. So this command will update the Docker configuration. Now we will be able to connect to the artifact registry. So let's copy this. So here as you can see, this is setting the project ID. It's getting the project ID from this by executing this command gcloud config get value project. So it's getting the value of the project and setting the project ID there. So the export it creates a variable with the name project underscore ID. So let's copy this and execute it here. Now it is set. Now let's run the command to tag node-app :0.2. So let's build this. So here this command is used to build a Docker image and tag it with a specific name and version. So let's execute this command. Now let's run the Docker images command. Here you can see this got created. Now let's push this image to artifact registry by executing this command. So this will now push it to the artifact registry. Now the push is complete. So that build is complete now. So let's navigate to our artifact registry and check the repository. This is my artifact repository. So this is the image which we have pushed now. You can see the tag. So now let's test the image. So we will stop and remove all the containers by executing this command docker stop docker rm. So docker stop and docker rm will stop and remove all the containers. So let's copy this. So this docker ps-q, this will get all the containers details and it will stop those containers and then it will remove those. So let's copy these two commands. Let's execute it here. So let's execute docker ps command to verify. Yeah, here you can't see any containers because we have stopped and removed it. Now let's move ahead and let's run the following command to remove all the docker images. Again, we need to remove all the docker images. So let's copy these commands. These are all the image names. So let's copy this and execute it here. When we execute docker images, it doesn't show anything because we have removed it now. So we don't have anything now. Like we don't have any docker images or containers. So now we have a fresh environment. Now let's pull the docker image from the artifact registry and create a container. Let me copy this first command, docker pull. So this command will pull the image. So this image from the artifact registry. So execute this. After that, let's run this. Copy this command and execute it. Now let's call this welcome to cloud. You can see now. Now you can see a container running. So what we did just now is we have pulled the docker image from the artifact registry and executed it. And we have built a container out of that image. So as you can see, a container is running here now. Now you can click on check my progress. This task should be completed. In this lab, we learned how to use the public images from the Docker Hub, how to build the own container images and push them to the Google Artifact Registry, how to debug the running containers, and how to pull the images from Google Artifact Registry and run the containers. So that's it for today's lab. If you found my video helpful, please like and subscribe to my channel and stay up to date with the latest content on my channel. Thank you all for watching.